Good morning all. Today we are going to start fourth unit, structural pattern, and in this we are going to see the bridge design pattern. So the main intent of the bridge design pattern is and is this splits a large class or a set of closely related classes into separate hierarchies, that means abstraction and implementation, and which can be developed independently of each other. And this bridge design pattern is a structural design pattern. Coming to the motivation, here we are going to see the example of a geometric shape class with a pair of subclasses. So here we are seeing a shape, and for that subclasses we have a circle and a square. So now we want to extend this class hierarchy and incorporate the colors to the shape. So here we have selected two colors, red and blue. So since we have already have two subclasses, that is circle and square, so now we are going to create four class combinations, that is red circle, red square, blue circle, blue square. So here the number of classes of combinations are more. Suppose we want to add a triangle to this particular shape. Again we have to add red triangle, red, blue triangle. So suppose if at all we want to add a different color, third color, again we are going to add the circle, square, etc. So this is a problem here. So here adding new shape, types and colors to this hierarchy, then it will become a very big, that means hierarchy will grow it exponentially. So in order to solve this type of problems, we are going to solve, we are going to use a bridge pattern. So here the bridge pattern attempts to solve this problem by switching from inheritance to the object composition. That means here we are not going to follow the inheritance, but here we are going to follow the object composition. What this means is that you extract one of the dimensions in a separate class hierarchy so that the original classes will reference an object of the new hierarchy instead of having all its states and behaviors within one class. See here, we have a shape. We are going to draw the shape, and here we have the two subclasses, circle and square. Now we have extracted color related code into it another class, and this class has the two subclasses, red and blue. Now the shape class gets a reference field pointing to one of the color objects. So the problem became easy by using the bridge design pattern. Coming to another example. So here, for example, we have a desktop, that is of Apple, and we have another operating system, Windows, and we have another operating system, Linux. So now our app which we have developed has to be execute or able to monitor the three different operating systems. Monitor in the three different operating systems. So here a multi-platform framework is there. So that means whenever we want to execute or whenever we want to open the application in Apple, so now we have to change the code. So in order to solve this type of problems, we are going to use a bridge pattern. This suggests that we divide the classes into two hierarchies. First one is abstraction and the second one is implementation. Abstraction, the GUI layer of the app, and the implementation is operating systems API. So here the abstraction object controls the appearance of the app, delegating the actual work to the linked implementation object. And here either it may be a Linux or Windows or anything, so the same GUI will work. As a result, we can change the GUI classes without touching the API related classes. Moreover, adding support to another operating system only requires creating a subclass in the implementation hierarchy. Coming to the structure, so here we have a client, abstraction, implementation, refined abstraction, and concrete implementation. So here the abstraction provides high-level control logic. It relies on the implementation object to do the actual low-level work. And the implementation is an interface which declares the interface that's common for all concrete implementations. And here an abstraction can only communicate with an interface implementation object via methods that are declared here. The abstraction may list the same methods as the implementation, but usually the abstraction declares some complex behaviors that rely on the wide variety of primitive operations declared by the implementation. And the next participant, concrete implementations. This contains platform-specific code. And the next one is refined abstractions. This provides variants of control logic like their parent. They work with different implementations via the general implementation interface. And the next participant, client, is only interested in working with the abstraction. However, it's the client's job to link the abstraction object with one of the implementation objects. Applicability. The first one is where we are going to apply this particular bridge pattern. First one, use the bridge pattern when you want to divide and organize a monolithic class that has several variants of some functionality. That means the bigger a class becomes, the harder it is to figure out how it works, and the longer it takes to make a change. The changes made to one of the variations of functionality may require changing in the entire class, which often results in making errors or not addressing some critical side effects. So here the bridge pattern lets us to split the monolithic class into several class hierarchies. After this, we can change the class in each hierarchy independently of the classes in the others. This approach will simplify the code maintenance and minimizes the risk of breaking existing code. In the second applicability, we can use the pattern when you need to extend a class in several orthogonal dimensions. That means the bridge suggests that we have to extract a separate class hierarchy for each of the dimensions. The original class delegates are the related work to the objects belonging to those hierarchies instead of doing everything on its own. And third one is how to use the bridge if you need to, that means we are going to use the bridge if we need to be able to switch implementations at runtime. And this is an optional. So here the bridge pattern lets us to replace the implementation object inside the abstraction. The last item is the main reason why so many people confuse the bridge with the strategy pattern. Remember that the bridge is more just like a certain way to structure your classes. It may also communicate intent and a problem being addressed. Coming to the pros and cons, the advantages and disadvantages. With this particular bridge pattern, we can create platform independent classes and apps, because with this particular app, a single abstract class can access a abstract object, can access a different platform dependent, that means we can access any file which is there in a number of platforms, in any platform. The client code works with high level abstractions. It is not exposed to the platform details. And the third advantage, open or closed principle. We have introduced new abstractions and implementations independently from each other here. Single responsibility or principle. We can focus on high level logic in the abstractions and on platform details in the implementation. And the disadvantage of this bridge design pattern, we might make the code more complicated by applying the pattern to a highly cohesive class. Coming to the related patterns to the bridge, adapter, and this particular adapter design pattern can be used with the bridge design pattern. And the next bridge, state, strategy have similar structures, and all these patterns are based on the composition. But, however, they all solve different problems. And the abstract factory can also be used with the bridge. And here this pairing is useful when some abstractions defined by bridge can only work with specific implementations. In this case, abstract factory can encapsulate these relations and hide the complexity from the client code. And we can combine the builder with builder design pattern, that is, the director class plays the role of the abstraction while different builders act as implementations. So we have seen the complete bridge design pattern. Thank you.